Hello students, welcome to MemoNeet. How are you? Hope you're practicing questions from the PYQ book, learning hard, right? And clearing your concepts by using the videos which we are posting in the YouTube. And this is our fourth video for laws of motion. In our first three videos, we have studied about the first law, second law, and third law of motion. And there we also studied about inertia, impulse, laws of the law of conservation of linear momentum, and all. Right? I hope last three videos have made a lot of things clear to you all. And if still you have any doubt, you can post it in the comment box over here. Right? Now this video is for Newton laws of motion fourth part, in which we'll be studying about the friction. Right? Friction and so what is friction? Friction is a self-adjusting force. It's a kind of self-adjusting resistive force which occurs only when there is a relative motion between two surfaces in contact, right? So what is friction? Friction has we can say we can talk about 4 points when we talk about 3 points when we talk about the friction. So friction is what we are studying today, and things which we should know is friction is a resistive force. Resistive force, right? It means it is always in the direction opposite to the direction of motion. Second thing is it is self-adjusting. How it is self-adjusting we see. And third thing is it occurs when there is a relative motion between the surfaces in contact. Surfaces in right. This will always occur between two surfaces in contact. Now let's try to understand what this friction force does. Right. Suppose this is a horizontal surface, rough horizontal surface, and on this we are placing a block. Now if I try to push it, let's say with a certain force F, this block has a tendency of moving forward, but it is not moving forward, right? Then if I increase the force to a certain value, what will happen? At a certain value, this block will start moving. This block will start moving, right? So why initially the block was not moving? Because when I was pushing the block with the force F in the forward direction, there was a force acting in the backward direction, in the reverse direction. The force was acting in the reverse direction, and this direction and the force in this direction known as a frictional force. Why? Because this is opposing the motion of the block in the forward direction, right? In the forward direction. So this is the frictional force. Now if I go on increasing, if I go on increasing force, a time comes when this force is sufficient enough to overcome the frictional force, and then when the force applied, the external force applied overcomes the frictional force, the block starts moving, right? The block starts moving. So the frictional force can be basically divided into three types. Three types of it. One is your static, another is your kinetic, and third is your. Now see, let's see this example again in another way. Surface, and on the surface there is a block, and a force of F is applied in such a manner. The block has a tendency of motion in the forward direction, so it will experience a frictional force in the backward direction. Now, this frictional force is a static frictional force if the block is not moving forward when I'm applying a force F in the forward direction. I repeat, when I am applying force in the forward direction, the block has a tendency of moving forward, but it cannot move in the forward direction. And at that moment, it is experiencing a force in the opposite direction, right? In the opposite direction, and this opposite direction, the force which is being experienced is known as the frictional force, and this frictional force is categorized in the category of static frictional force, right? What static frictional force? And because the block is not moving, therefore the externally applied force is equal to frictional force. Now, if I keep on increasing this F, this frictional force will self-adjust itself and become equal to the externally applied force. That is why we call frictional force as a self-adjusting force, right? So, when we are applying a force on a body and the body has a tendency of moving in the direction of force, but it is not moving. At that time, the frictional force which is acting between the surfaces of the body, or the surfaces in contact, is the static frictional force, right? And the static frictional force is self-adjusting. It will increase or decrease or change as the external force changes, right? Now, then if I go on increasing the value of F, then at a certain value of F, what happens? It will start moving. The minimum value of F, the minimum value of the external force applied for which the body starts moving, is known as the limiting frictional force. So the moment at which the object started moving, at that moment, whichever frictional force was acting, or whatever the amount of the external force was acting, that amount of force is known as your limiting frictional, known as limiting frictional force. What limiting frictional force is? Limiting frictional force is the minimum amount of the force required to move the block in the direction of force, right? Minimum force, sorry, it is the minimum for external force required to move the block in the direction of the, right? Now then we have kinetic friction force. Now as soon as the externally applied force increases from the value of limiting friction force, what happens? The block starts moving in the forward direction. The displacement now is in the forward direction. Now, at this moment, still there is a frictional force acting in the opposite direction, and that frictional force, when the block is moving in the forward direction, is known as the kinetic frictional force. Kinetic frictional force. And at that moment, this kinetic frictional force is constant. This kinetic frictional force is constant, right? So, just to give an understanding of what these forces are and how they act, if I draw a graph like this, on which on the x-axis I plot the externally applied force, right? And on the y-axis I draw the frictional force, then this graph would take somewhat shape like this, right? Now this this is limiting frictional force. This is your limiting friction. This region is of static frictional force, and this value, this this value is your kinetic frictional force, right? This value is your kinetic frictional force. So what we see from here is that if I write like this is for kinetic frictional force is less than Fr, where Fr is the limiting frictional force, right? Fr is the limiting frictional force, and Fs we will call it as static frictional force. This is static frictional force. Your Fk will be your kinetic frictional force, and Fr we generally represent for limiting frictional force, right? Limiting frictional force. So from the graph, what we find is, from the graph we find, what are the findings from the graph? What we find is that Fk, that is the kinetic frictional force, is a constant value. First thing, this occurs when the body is in motion, right? Second thing about from the graph, what we get is this Fk is constant, and then second thing is your kinetic frictional force is less than limiting frictional force, right? Then next thing what we find is that your static frictional force is directly proportional to the externally applied force. That is, as the external force applied force increases, the static frictional force increases. Therefore, we have a straight line in this region. We have a straight line in this region, and then we have a constant value which is greater than the kinetic frictional force, and that is known as limiting frictional force. Limiting frictional force, beyond which the body starts moving in the forward direction, right? So these are the type of frictional force. Now, this when I write Fr, this Fr can be commonly used for any type of frictional force. Now, this frictional force is given by the formula Fr is equals to mu into normal reaction force, right? Now, where mu is known as coefficient of friction, right? And R is the normal reaction, normal reaction force, right? So, if a body is placed on a surface, it applies its weight mg in the downward direction and experiences a normal reaction force in the upward direction. So, if it is experiencing any frictional force Fr, so this Fr will be equals to mu into capital. That is, the frictional force is directly proportional to the normal reaction, right? Is directly proportional to the normal. Now, if the frictional force is static frictional force, then we write it as mu s into, if it is your kinetic frictional force, we write it as mu k into r, right? And if it is, let's say, Fr, we simply write mu into, right? Fr is a limiting frictional. So till now what we have studied, that if a body has a tendency of moving and it needs to slide over a surface, then the body experiences a resistive force which is known as a frictional force, and this frictional force is a self-adjusting resistive force which occurs only when there is a relative motion between two surfaces which are in contact, right? This frictional force is of three types: it was kinetic frictional force, static frictional force, and limiting frictional force. When you're applying a force on a body, it has a tendency of moving, but it is not moving. At that moment, the frictional force which is acting on the body is known as static frictional force. Now, if you keep on increasing the value of the external force applied, what will happen? The force of the static frictional force, magnitude of the static frictional force will also increase, and it will increase along with the externally applied force. At that moment, the static frictional force will hold the value equal to the externally applied force, right? I repeat, when the body is not moving at that moment, the frictional force which is acting is the static frictional force, and it is equal to the value, it is equal to the external force applied. If I increase the external force, again the static frictional force will increase. After a level, what will happen? The block will start moving. The minimum force, the minimum value of the force at which the block starts moving, the minimum value of the force at which the block starts moving is known as the limiting frictional force, right? And when the block starts moving, the frictional force between the two surfaces which are having relative motion, that frictional force is known as kinetic frictional force. So the frictional force is given by the formula mu r. Why? Because friction is directly proportional to the normal reaction force. Friction is directly proportional to the normal reaction force. So removing the proportionality, we will write frictional force is equal to mu into r, and this mu is the coefficient of friction. For static frictional force, the coefficient is mu s. For kinetic frictional force, the coefficient is mu k, and for limiting frictional force, you simply write it as mu, right? So this is what about is friction. Introduction about friction. Now the next thing which we are going to study is the angle of friction. Is the angle of, right? Now let's draw a diagram. Surface. This is a block, right? And this is a weight which is acting on it. It will experience a normal reaction force in the upward direction. Then there is a force which will be applied on it, let's say in this direction, let it be F, right? And because of this, it will have a resistive force acting in the opposite direction, and let's say it as FR, right? Now, if we find the resultant of this frictional force and the normal reaction force, we'll get this, vector, right? We'll get this. Now, the angle between the resultant and the normal reaction force, if I mark it as theta, then this angle theta is called as angle of friction. Angle of friction. Now, if we look into this triangle, right? For theta, this will be perpendicular and this will be base. So this is nothing but r. This is nothing but r, and this vector, this portion is nothing but equal to the frictional. So from here, if I write as tan theta, it will be equal to r upon frictional force. Oh, sorry, b perpendicular. Perpendicular is fr upon base, it is r, right? And we know that fr is nothing but mu into r. If I put this value here, what I'll get is tan theta is equals to mu into r upon r. This r and r cancels out. What we get is your tan theta is nothing but equals to the coefficient of friction, right? So from here what we get is the tan of angle of friction. Tan of angle of friction. that is tan theta is equals to mu, that is the coefficient of friction between the two surfaces, right? The two surfaces. Now the next thing which we are supposed to know is angle of repose. Angle of repose, right? So now the angle of repose, right? So for angle of repose, understand it, let's draw an inclined plane. Now suppose there is an inclined plane and the angle of inclination is theta and there is a block placed on the surface, right? So its weight will be acting in the downward direction, mg, and this mg can be resolved in its two components. One component is along the surface and another is perpendicular to the surface, the inclined, right? So if this angle is theta, this angle will also be equal to theta. So this force which is perpendicular, this component is perpendicular surface will be equals to mg cos theta, and this which is along the inclined plane will be mg sin theta, right? Mg sin theta. Now because of this mg sin theta, this block will have a tendency of moving forward, but it is not moving forward. Now if I go on increasing the value of theta, if I raise this inclined plane and go on increasing the angle of inclination, that is I keep on increasing the value of theta, a certain value of theta for which the block just slides moving with an acceleration equals to 0. That is, it will start moving in this direction with a equals to 0 and some velocity, right? So when it is moving in the forward direction, it will experience a force of mg sin theta in the forward direction, right? And some frictional force in this direction. So since acceleration is 0, the frictional force will be equals to mg sin theta, right? So the angle for which it starts moving is known as the angle of repose, right? Angle of repose. Now let's again draw the same diagram and try to find out the value of angle of repose. Now suppose this is the angle of inclination for which it has started moving. So this will be known as angle of repose. Now this is the block, weight will be acting downwards. This will be mg, right? So one perpendicular to the inclined plane, another along the inclined plane. This is, we have resolved our mg into two components, right? Mg into two components. So this is equals to mg mg sin phi. This will be equals to mg cos phi. Now because of this mg cos phi, there will be a normal reaction force r in the direction vertically upward but perpendicular to the inclined plane. So this will be r. Now since the block is moving in the forward direction, there will be a frictional force acting in the direction opposite the direction of motion. So this will be your frictional force, right? This will be the frictional force. Now from this diagram, we can say that the frictional force is equals to mg sin theta, and the normal reaction force R is equals to, no, it's not theta, it's phi, it's phi, right? So, and R is equals to mg cos phi. So, we can write this equation as mu into R is equals to mg sin theta and divided with the another equation, the second equation, that is R, and this becomes upon mg cos phi. It's phi. I'm repeatedly saying it at theta. It's phi, right? So from here, r and r go cancels out. What we get from here is mu is equals to this mg and mg also gets cancelled out. We get mu is equals to tan phi, right? Mg is equals to tan phi. So from here, what we get is that the tan of angle of repose is equal to coefficient of static, coefficient of friction. That is the kinetic friction of it, right? Because the block had started moving and it is moving with zero acceleration. So tan phi, that is the angle of repose, the angle tan of angle of repose is equals to the coefficient of kinetic friction, right? So we finished up with the angle of friction. Now we have finished up with the uh, what angle of repose. Now let's see some numericals related to these concepts. Let's first see this question number one. This question number one says that a block of mass 2 kg is placed on the floor. The coefficient of static friction is 0.4. A force of 2.5 Newton is applied on the block as shown in the figure. Calculate the force of friction between the block and the floor. So what they have given to us is there is there is a horizontal surface. On this horizontal surface, a block is in place and we are applying a force F on it. And this F is equals to how much? 2.5 meters. Right? So the coefficient of static friction is the price of the figure. Calculate the frictional force between the block and the floor. Now the weight of the block is mass of the block is 2 kg and coefficient of friction is 0.4. So let's calculate the limiting frictional force. So limiting frictional force is equals to mu into r. So it will be equals to mu is 0.4 and here the normal reaction force is nothing but equal to the weight of the body. So we'll write it as 2 into g. Let's take g as 9.8 or just for our calculation let's take it as 10. Right? Let's take it as 10 just to make it easy. So it will become equals to 4 to the 8. 8 Newton, right? If we take it as 9.8, it becomes 7.8. So what we find from here is the thing which we need to understand is that the limiting friction force is 8 Newton, right? It means we need at least 8 Newton of force to move this block forward. Now, if the external force applied is 2.5 Newton, it means the external force F is less than the limiting frictional force. Now, if this is the case, then this frictional force is equals to the static frictional force. And static frictional force being self-adjusting, so the static frictional force will be equal to the external force applied. So the frictional force in this case, because they're asking you to calculate the force of friction between the block and the floor, so the answer would be 2.5 Newton, right? 2.5 Newton because the externally applied force is less than the limiting frictional force. Therefore, the friction force in picture here is the static frictional force, and the static frictional force being self-adjusting, its value will be equal to the externally applied force, and the externally applied force over here is 2.5 Newton. So the correct answer for this will be 2.5 Newton, right? Now let's get into question number 2. The question number 2 says that a force of 49 Newton is just sufficient to pull a block of wood weighing 10 kg on a rough horizontal surface. Calculate the coefficient of friction and the angle of friction. So if this 49 Newton is just sufficient to pull the block, then it means this 49 Newton is nothing but the limiting frictional force, right? Now, if this is limiting frictional force, the frictional force is given by mu m g by mu m g, because here r is the mass of the body, weight of the body is equals to 49. What they have given to us is that the weight or the mass of the body is 10 kg. Find we need to find the coefficient of friction. So mu into m is 10, and here let's take g as 9.8 is equals to 49. So from here we'll get mu is equals to 49 upon 98, which is equals to 0.5, right? So the coefficient of friction mu is equals to 0.5. Now they are also asking you to calculate the angle of friction, and you have just seen that angle of friction is given as tan theta is equals to mu. So theta. So theta will be equals to tan inverse mu. So theta is equals to tan inverse 0.5, right? So this is the angle of friction for this scenario. Now let's see the next question. The next question says, let's see this numerical. Now what is happening in this numerical is they say that a coefficient of friction between the ground and the wheel of a car moving in a horizontal road is 0.5. If the car starts from rest, what is the minimum distance in which it can acquire a speed of 72 kilometers per hour? So see, since it is starting from rest, it means it is overcoming the limiting frictional force. So limiting frictional force Fr is equals to mu into R, and the force applied externally on the car or by the engine of the car will be equal to F, and that can be written as F is equals to M into A. And if the car is starting from rest, it would start moving only when this limiting frictional force is equal to the externally applied force. That means we can say that mu into R is equal to M into A, and R is nothing but mg, that is the normal reaction force. So U mg is equals to M into A, and from this here M and N goes off, we get mu into G is equals to A. So A, acceleration A will be equals to mu is 0.5 and G is 10. So we get A is equals to 5 meter per second square. We got the acceleration. Now what they are saying is the car is starting from rest. So u is equals to 0. Final velocity v is equals to 72 kilometers per hour. This is nothing but 20 meter per second. I hope you know the conversion. You multiply this by 5 by 18, you will get in meter per second, right? And they are acceleration we have is 5 meter per second square. They are asking us the displacement, right? So we will use the formula of the equation v square is equal to u square plus 2as. Putting the values we get 400 is equals to 0 plus 2 into 5 into s, right? So this will be equals to 400 is equals to 10s. So your s will be equals to 40 meters, right? So the answer for this question will be 40 meters. So in 40 meter, it will acquire speed of 20 meter per second or 72 kilometers per hour. Now let's see some more concepts. Let's just see the more concept about the inclined plane. The most important thing on the inclined plane is the resolving the force. Most commonly found, or the very first step for the inclined plane will be resolving the force, and that is if a block is being placed, let's say if a block of mass m is being placed over here, it will have its weight equals to mg acting perpendicularly downwards, and if this angle is equal to theta, if I draw a line which is perpendicular to the inclined surface, this angle will also be equal to theta, right? Now what I'm doing is I'm resolving this vector into a vector which is perpendicular to the inclined plane and a vector which is along the inclined plane, right? So if this is theta, this will become mg cos theta and this will become mg sin theta. Now because this mg cos theta is acting perpendicular on the inclined plane, therefore this will result in the normal reaction force R, right? So from this, whenever a block is placed on an inclined plane, we always take R is equal to mg cos theta. Why we are taking as mg is equal to R is equal to mg cos theta has been explained here, right? And the force, one of the force which is acting in the forward direction is mg cos theta, right? So let's see a numerical for it. It will help you to understand it much better. Numerical says that a block of metal of mass 50 gram when placed over an inclined plane at an angle of 15 degrees slides down without acceleration, right? It means they are saying that initially if this is the inclined plane and the angle of inclination is 15 degrees, the block is sliding down without any acceleration, that is acceleration is equal to 0. So as we see, we saw just now, there will be a force acting in this direction, which will be equals to mg sine theta. So it will be mg sine 15 over here, right? And because it is sliding down without acceleration, there will be some frictional force also acting over here, and the frictional force Fr is equals to mu mg, sorry, not mu mg, it will be mu r. And here we have seen that this mu r is equals to this force which is mg cos theta. So the frictional force will be Fr is equals to mu mg cos theta. Now because it is moving with zero acceleration, therefore we can say that mg sin theta is equals to mu mg cos theta, right? So this mg and mg goes off. What we get is mu is equals to tan theta. It means the coefficient of static frictional force is equals to tan 15. The value of tan 15 will be equal to the coefficient of static friction. Now they are saying that it is sliding down without acceleration. Now if the inclination is increased by 15 degrees, what would be the acceleration in the block? They are saying that it is increased by 15 degrees. So if we are increasing it by 15 degrees, now the inclination becomes 30. Angle of inclination becomes 30. If this is 30, this is the block, it will move downwards with mg sin 30, right? The frictional force Fr, here in this direction it will be what? Mg cos 30. How we are getting this mg sin 30, mg cos 30 I have already explained, and in this direction it will be R. So from here we'll get, and still the block is moving in this direction with some acceleration, right? So from here we can say that mg sin 30 minus Fr is equals to m into a, right? And R is equals to mg cos 30. So from first we can write is mg mg sin 30 minus mu mg cos 30 is equals to m into a, right? Now taking mg common, what we get is sin 30 minus mu cos 30 is equals to m into a. So this m and m cancels out. What we get is acceleration is equals to sin 30 minus mu times of cos 30 into g. So mu can be taken as what? How much? Mu can be taken as tan 15, right? Tan 15. Putting the value of tan 50 and sin theta, we can easily get the value of acceleration, right? This is how we will be doing this numerical. So the next numerical is, this is related to something other, something else. So let's see this concept first. The very first thing is, if a body is under circular motion, right? If a body is moving in a circular motion, it has to produce or it has to experience a centripetal force, right? A force which is acting radially inwards, right? Without any centripetal force, there cannot be a circular motion. The centripetal force is given by mv square by r, where v is the instantaneous velocity, instantaneous linear velocity v. Or we can say that the centripetal force is equals to m r omega square, where omega is the angular velocity and r in both the cases r is the radius of the circular motion and m is the mass of the motion, right? So this is the formula for calculating centripetal force, and the centripetal force is the force because of which a body undergoes a circular motion. See, if a body is moving in a direction like this, right, and if it experiences a force F in the direction perpendicular to its motion, what will happen? It will start moving in a circular path, right? And it will form a circular motion. So this, to cause this circular motion, this centripetal force must be there. Without the centripetal force, there cannot be a circular motion. Now, why we are talking about circular motion? Because suppose a body is moving in a straight line and now if the body wants to take a turn. So take a turn, it has to undergo circular motion, a partial circular motion, let's say, but it would be a circular motion, right? Now, to take a turn, it has to take a round, or it has to make a arc. To make this arc, there should be some centripetal force acting inward, right? There should be some centripetal force. Now, from where to produce the centripetal force? Now, when we are moving on a road and we need to take a turn, what we'll do? We will we incline ourselves inwards the inward of the curve. If we are moving towards left, we will incline ourselves towards the left, and when we are inclining ourselves towards the left, the lower portion is moving towards the right. Right? The lower portion will be moved towards the right, and when the lower motion, which is in contact with the road, moves to the right, what will happen? It will produces a frictional force which will be acting in the left direction, and this frictional force will be used as a centripetal force. Now, to just understand it well, let's see this diagram. Let's see this diagram. Now, see the car. Now, this is the path of the car, and let's say this is the road. This is the road. Now, when the car is moving straight, its inertia of motion wants it to move straight. But now, when it has to take turn, the car will have a tendency because of inertia of motion to move in this direction, and because of which the car will experience a frictional force in this direction, and this frictional force will help the car to take the turn. That's what is being shown over here. See, this is the weight acting downwards. Then there is a normal reaction force. Again, this is because of this mg Normal reaction force is because of mg cos theta, right? Mg cos theta. So we have not drawn this over here because we do not need mg cos theta right now, because we will be resolving this normal reaction force into its component r cos theta and r sin theta. Right? Now this frictional force which is acting as a centripetal force, how it will be acting as a centripetal force? Because if we resolve this F in a component like this and like this, which has been drawn here, right? So this force will be F cos theta and this vertical force will be F sin theta, right? F sin theta. So from here we can say that this F cos theta and r sin theta both are acting as a centripetal force. So we can say that r sin theta plus f cos theta is equals to mv square upon r, where r is the radius. Let's write it r mv square upon r, small r, right? And this r cos theta, r cos theta and f sin theta, they are opposite direction. So what we can say is your f cos theta, f sin theta, f sin theta minus r cos theta is equals to mg, right? Mg, or you can say, yeah, this is it. F sin theta minus r cos theta is equal to mg. Or if you can understand it like this, see this mg is in downward direction, f sin theta is in downward direction, and r cos theta is the upward direction, but there is no movement in the vertical axis. So all the forces, the sum of the net force is equal to 0. So we can say that the vertical force is equal to the vertically upward force is equal to vertically downward force, that is r cos theta is equal to mg plus f sin theta, f sin theta. So we can say that f sin theta, hold on, so we can say that your r cos theta minus f sin theta is equals to mg. So written this wrong over here. We will write r cos theta minus f sin theta is equals to mg. So let's rewrite the equations again. Rewrite the equation. It is r sin theta plus f cos theta is equals to m b square upon r, and r cos theta minus f sin theta is equals to mg. Now dividing the two equations, what we will get is r sin theta plus f cos theta upon r cos theta minus f sin theta is equals to b square upon rb, right? Now dividing with r cos theta in the numerator and denominator, we get 1 plus f by r into tan theta. Oh, no, f by r will be r cos theta will be tan, dividing with r cos theta In numerator and denominator, we will get r cancels out. We get tan theta plus f by r upon 1 minus f by r tan theta is equals to b square upon rg. So this will be equals to tan theta plus f by r is nothing but mu upon 1 minus mu tan theta is equals to b square rg. Now, if suppose the coefficient of friction mu is equal to 0, then in that case tan theta will be equal to b square upon rg. I'm sorry, here it will be small r. Two places where written capital R, it will be small r and small r, right? So tan theta is equals to b square upon rg. This is the formula by which we calculate at what angle the road should be inclined to give a safe turn to the vehicles which are moving with a velocity v for a turn of radius r, right? So this formula which is being used for banking of road. So let's see one numerical related to it. Alright. It says a circular race track of radius 300 meters is banked at an angle of 15 degrees. Right? Now, if the coefficient of friction between the wheel and the race car and the road is 0.2, what is the optimum speed of the race car to avoid the wear and tear on its tire and maximum possible speed to avoid the slipping? Right? So what they are saying is that radius small r is equals to 300 meters, right? Small r is equals to 300 meters, and the angle of inclination is theta is equals to 50 degrees. The coefficient of friction and mu is equals to 0.2. What they are asking is in the first part is what is the optimal speed of the car to avoid the wear and tear, right? So we know that tan theta is equals to v square upon r g. So from here we can say that v is equals to under root of tan theta r g, right? So v is equals to under root of tan 15 into 300 into g, if we take it as 10, then putting the value of tan theta and solving, we will get v is equals to 28.1 meter per second, right? So it's a simple calculation. We put the value of tan theta, tan 15 there. Now in the second part, they are asking you wear and tear on its tire and maximum permissible speed to avoid slipping. Maximum permissible speed to avoid slipping. For that, we will use the formula your v square upon rg is equals to tan theta was mu was this one, this one, right? This is mu plus tan theta, mu plus tan theta upon 1 minus mu tan theta, right? Again, the putting the value, that is, we put r is equals to 300, put d is equals to 10, and mu is equals to 0.5, right? 0.5 has been given to us, 0.2 mu has been given to us as 0.2, and tan theta is equals to tan 50, right? Putting these values, we will and calculating, we will get v is equals to 38.1 meter per second. So this is the maximum value of the velocity. That is, this is the maximum velocity with which the vehicle can cross that turn, so to have a safe turn, right? So I suppose this is all for the leftover part for laws of motion. So what we have studied till now is, we studied in the first part about the frictional force, that whenever a body has a tendency of moving or sliding over a surface, it will experience a frictional force, and that frictional force were categorized into three categories, that is a static frictional force, kinetic frictional force, and limiting frictional force. Static frictional force is self-adjusting, and it increases or decreases value as the value of external force increases or decreases. Kinetic frictional force has a value less than the limiting frictional force and is a constant value, and it comes in picture when the body starts moving. Limiting frictional force is the maximum value of static frictional force and the minimum value of the external force at which the body starts moving. This is the graph which represents the kinetic and static frictional force, right? Then we saw that the formula for frictional force is mu into r. Then we saw the angle of friction. Then we saw angle of repose, and then we saw the numericals on it, and after that we saw the banking of load. So these are the concepts on which we have studied in this video. Go through the video just for your practice. Solve more and more numericals. Go to the PYQ book. See what type of numericals are coming in the Neet examinations. Practice that type of numericals more from the PYQ book. You will have a better understanding for the steps of the solutions for various numericals there. So, good luck. Prepare for the BTS 7 and score well. That is all from my side today.